Hi everyone, this is Ken 121, week number 13, and today we'll be talking about creating functions in Python. If you recall, we started this course looking at loops, for loops, while loops. We then looked at, plotting, um, how to do some data analysis with plotting, how to fit equations, how to determine the R-squared parameter. And then we moved on to do some linear algebra, matrix algebra, how to solve systems of linear algebra. And a lot of the times we have to repeat commands a bunch of times, right? So you have a certain set of actions which you want to do maybe 4, 5, 6 times. And most of the time you just copy paste the script and do some modifications. And today we'll talk about functions, and what a function allows you to do is that it allows you to call the list of commands when needed, just using one line. So instead of retyping the entire list of commands or the entire script every time you want to implement the series of commands, you can just use a function to do this for you. And functions are used to easily implement repetitive tasks or calculations. And we'll see throughout today's tutorial how to create functions and how to call them. And it's a very simple idea. And basically in Python, a function is defined using the def keyword, right? And this is really important to remember. You're just defining a function. So for example, here I have def my underscore function. I'm defining a function called my function. And what this function does is that it prints the text hello world, right? So every time I type, as you see here, to call this function, I just have to type my underscore function. And every time I type this command, I'm going to get the result of hello world printed out. Let's test this in Python. So I'm going to copy these two lines, and then I'm going to go to Spider here just to test them. As you can see, let me zoom in. So we have define, that's the command define, my underscore function. This is the function name. I have two brackets for now and then dot dot. And what this function does is that it prints hello world. And if you run this as is, you're not gonna get an output, right? It's just gonna run. However, now if I call my underscore function right here and I run it, it will print hello world, right? So every time you call this function, if you call it a bunch of times, it will do this list of commands a bunch of times, however many times you call the function. And an extension of this logic is now instead of having just one print, we have 50 command lines. And instead of retyping them every time, I just call them and they will be executed. Okay, let's go back to the lecture here. And as you can see here, my function, or the first function we created, does not really take any inputs. It just has a name and it does an output. However, a lot of times we want to create functions with arguments. And what this means is that I feed the function information, and then the function uses this information to execute a set of commands. And this is really more useful to you as an engineer, because a lot of times, let's say you want to create a function that will solve differential equations. You need to give the function maybe the constants of this differential equation, and then it's going to solve it. Or you want to have a function that will plot two arrays. You need to feed this function the two arrays, and it will generate these plots. Okay, and this is called functions with arguments. You basically need to feed the function these arguments, and then it will be able to implement them. So if you have an example here, define print info, and this function here takes two commands, name and age, right? And what this function does, this function prints the past info as a function. So if it's going to print name and age, okay? And then it's going to return name of the guy is equal to this, age is equal to that. And let's test this function. I'm going to go to Spider here and we're going to test the function with arguments. I'm going to start a new script. Let's delete this information. And here we go. So again, when creating a function, the structure is the same. I have define, very important. Print info, this is the function name. You can call it whatever you want. The two brackets, in the brackets, I have the arguments which this function is going to use, and then a colon at the end of the function. And then the list of commands have to be indented. As always with Python, we use the indentation to indicate priority or hierarchy. So what does this function do? So this is just a comment, you can forget about it. So what it's going to do is that it's going to print name. So it's going to append the text you give it next to name, and then it's going to append the number you give it next to age. Okay, so let's try and run it. So if I run this command, nothing's going to happen because we're not really doing anything. However, if I call this function, so if I call this function print info, and the way to call it, I'm going to say name is equal to, let's use a name, say Lionel, and age will be 36, right? So if I use these two functions, these two commands, and call the function print info, and then I execute this command, I'm gonna get name Lionel, age 36. Okay, and this is how you really call a function, or this is how you really feed a function arguments to use it. A common modification, so let's say you want to, or an annoying thing which happens is that when calling a function, I have to write the variable name. So let's say you write a function, use it a lot, that you don't remember what these parameters are, right? You just want to feed it the information and for it to run directly. An easy way to do this is to initialize these arguments. So if I initialize these arguments, so if I initialize this argument as a string, and I initialize the second argument as a number. And all I did here is I put equals, parentheses, quotation marks, basically initializing this argument as a string, and then equals 0, initializing this argument as a number. So now when I recall this function, so let's say I'm recalling this function print info, I'm going to use, let's see, ABC and number 1, 2, 3, 4. And now if I run it, so it's not happy. Let's see. Oh, okay, because this is a string, I have to put quotation marks around it. Now if I run it, it will give me the output directly, right? And what this does by initializing these arguments, what you're doing is that you're able to feed your function directly the information without having to list or rewrite the argument names or the variable names every time you call this function. Okay, so again, let me go over it. So in case you don't initialize your arguments in a function, so if I just say name and age, when calling the function, I have to specifically write these arguments as is. Name equals, age equals, right? This is if it's not initialized. I have to rewrite the variable name here and the variable name here. If you don't want to do that, you can just initialize these arguments. So I'm going to initialize this as an empty string and initialize this as 0. And then when calling the function, I don't need to write these variable names. I just put in the information directly and the function is going to execute it. Okay, and this is the difference between initializing the arguments in a function and not initializing the arguments in a function. Usually you want to initialize them so that it makes it easier for you to recall the function every time. Good. Let's go back to our Word file here, and here this is what I'm talking about here. If you don't want to initialize the arguments, you're gonna have to call them, right? So if you don't initialize them here, you have to call them directly when calling the function. And this is very important to remember. This is one of the common errors why some of these functions don't run as expected, etc. On the other hand, if you initialize the arguments directly when defining the function, then you don't have to write the argument names. You can just feed the information directly and the function will execute. Okay, this is the basic idea of function. You just define it, brackets, be careful with your syntax, with your indentation, and you can use a function to really carry out a list of commands in any way you want. Okay, so let's do some practice exercises. And I'm going to do 3 practice exercises. The first one is will cover loops, right? The second one will cover plotting. And the third one will cover systems of linear equations. Okay, so let's start off with the while loop practice example. So recall homework problem number 4 from week number 3, while loops. And in this homework problem, you were asked to write a code using while loops that will display the numbers from a user specified start number to a user specified stop number. And you're asked to test the program using 2 examples. And this was the script we generated back then in solution to this homework problem. So let's test. So let's copy the script and test it in Spider first. Let me share my screen back to Spider. And I'm going to get rid of this. And let's just paste this information here. And basically what it's doing is that I'm defining 2 variables, start number and stop number. The start number is being defined using a user or, a user specified input. So I ask the user enter the starting number, and then I ask the user to enter the stop number. And then I implement this information in this loop here. So what I do is I basically print all the numbers using a while loop between the start number and the stop number. So let's test it. So if I run this script here, as you can see in the shell in the bottom right hand corner, it's asking me enter the starting number, output 1, and then it will ask me to enter the stop number. I'm going to put 7, and then it just lists the numbers from 1 to 7. Okay, so let's say I want to do this thing a bunch of times, and I need to basically write a function to do it, right? So instead of having these 2 lines every time I want to do it, I just want to have a function which will do this for me to make my life easier. So let's define a function. So I'm going to define a function, and I will call this function show numbers. Okay, define a function, show numbers, brackets, column, and this is how I'm defining the function. And next thing I'm going to do is I'm going to indent these guys, and this is very important. You need to indent them, otherwise, so that Python recognizes this hierarchy of commands. Okay, now let's go back to our define line here, show numbers. And what information do I want to feed this function? I need to feed it the start number and the stop number, right? So I'm going to say start number, stop number. So I have my 2 arguments here, start number and stop number. And then instead of every time having to write out these 2 variable names, I'm going to initialize them. So I'm going to initialize this as 0, and then I'm going to initialize this as 0 or 1. It does not matter. You can just initialize it whichever way you want. Okay, so I created my function. So now I don't need these 2 lines, right? I can just call show numbers and it will implement this script. So let's run it. And when we run it without calling a function, nothing will happen. So in the shell, it will just show you a new line. But when I call the function now, so if I say show numbers 1, 7, and run the script, it will show the numbers from 1 to 7, right? If I say show numbers 13 to 44, whatever, it will show the numbers under each other. And as you can see, it will run this list of commands as many times as you want. Okay, so this is how you convert this exercise into a script or into a function, sorry. Take a minute, try to absorb what we did. And really the main thing is just defining the heading and defining what information you want the user to feed when calling the function name, and then initializing these arguments, right? So in this case, show numbers, start number, stop number, and I initialized them to 0 and 1. And then I run or I call the function and it will execute it whichever way. And again, if I put something which doesn't make sense, let's say I wanted to run show numbers from 13 to ABC, it will give me an error. It will tell you ABC is not defined. So when doing these exercises, maintain basic logic. Be careful with the spelling. So, if I call the show numbers with a capital S, it will not work out. Tell me it's not defined, because Python is very sensitive to these capitalizations. Okay, good. Let's go back and do exercise number 2. Okay. So in exercise number 2, I'm going back to week number 6 when we talked about plotting. And if you remember back then, we said the following set of experimental data was measured in a reactor for the concentration of species A versus time, right? And here you have time, and concentration is basically a typical experiment in chemical engineering where you run a reaction and you measure how fast it goes or measure its time-dependent rate. And back then we wanted to use Python to write a script to generate 4 plots of concentration versus time, concentration squared versus time, ln CA versus time, and 1 over CA versus time. And we wanted to present the plots side by side in a 2x2 figure and clearly label your axes and provide a title for each plot. Okay, so initially let's, and if you recall, it was quite a long script back then. Let me see, let me open it first and we'll run it and then we'll figure out how to be converted to Python. To a function, sorry. So everything is in Python, right? Okay, and this is the script we had back then, week number 6, and you can find all these scripts on Blackboard. And basically I have my time array, I have my concentration array. We then ran a for loop to determine CA squared, determine ln CA, and to determine 1 over CA. If you forgot this stuff, you can go back and watch that video. And then we generated the plots. And if I run this, I should get the 4 plots of, concentration versus time, concentration squared versus time, ln concentration versus time, and 1 over concentration versus time. And, we changed the colors a bit. I remember maybe made one blue, made one red, and made one, I don't know, yellow maybe. But basically we're able to generate the 4 plots next to each other. Good, so what I'm gonna do now is I'm gonna generate a command or a function that will do this automatically. First of all, let me get rid of this thing. I don't want it to generate this figure every time. I just want it to generate the 4x4. So I got rid of the small script which had this, which generated this individual figure. Okay, let's clean things up and then let's run it again. Make sure it only generates the one 4x4 figure. Good. So now I'm going to convert the script into a function. And since we already have the script written down, it's a bit easier. What we want to do is find the point where we're going to define our function. And I think the point is here, right after or right before the commands start being implemented. I'm going to define a function here, and let's define it as concentration plots. And this is the function name, concentration plots. And this function, again, you need two brackets and dot dot. And before doing anything, I'm just gonna copy all the script and I'm gonna, press on tab to indent it so that the hierarchy is recognized, okay? And this is very important, just highlight the script and press on the tab button on your keyboard so that just everything just pushes to the side a bit for indentation. Good, so I defined my function, I gave it a name, concentration plots, and then it needs to take inputs. What are the two inputs we usually give it? It's these two arrays, time and concentration. So I'm gonna define the two inputs as t, and I'm just initializing it as an array. And my second input will be CA, and it's also being initialized as an array. Good, so I define my function concentration plots. I set my two inputs as array T and array CA. So now I'm gonna cut this information out. And that's it really. This is your function created. So if I run this command or run this script file, it ran fine, so I don't have any errors, but you don't get any results, right? So if I clean this result and I run it again, and in your shell, it will just run without any results. So what I want to do now is I want to call this function and test it. So first of all, so in calling this function, I'm gonna write my two arrays, T and CA, and then I'm gonna call the function concentration plots T, comma, CA here. And now if I run it, you should be able to see the figures, right? And this makes it easier because now if I change this information or if I have some other data I want to test, so let's say you have 20, you ran this experiment 20 times and you want to generate 20 4x4 plots. Instead of typing this, all of these lines every time, you just type it once and then call it 20 times. And this saves you a lot of, first of all, typing, but more importantly, it saves you a lot of memory space, a lot of computational power. You have a more efficient code and you can do things more cleanly, and makes it easier to troubleshoot, right? Because if something looks wrong and you catch an error here, you don't need to change it 20 times. You just change it once here, and then it will be fixed in all of them, okay? So this is how we changed this script into a function. Good, and this is example number 2. Take your time, try it, think about it, and please come to office hours every day from 5 to 7 if something's not clear. And I already changed it here, so in the Word file it's already changed. So if you look through the Word file and watch the video at the same time, the Word file is already changed into a function. Okay, let's look at our last example here. And this was from last week where we solved a system of linear equations in Python. So if you recall, we used matrices to solve systems of linear algebraic equations, and this is the basic script. So if I have two equations, 4x plus 3y equals 20, minus 5x plus 9y equals 26. In order to solve these, I'm going to create an array A containing the coefficients of the equations on the left-hand side. So A will contain 4, 3, minus 5, 9, and then I'm going to create a vector B containing the numbers on the right-hand side, 20, 26. And then, you can check if the determinant is non-zero. Then you find the inverse of A and multiply the inverse of A by B, or you can just solve it directly, right? Okay, we're missing a line here, but that's fine. I'm gonna delete this to make it easy. So if you look at last week's video, we either multiplied the inverse of A by B to get the solution, or we used the command solve directly to get the solution. So let's copy the script and let's test it. So I'm gonna go to Python again, or to Spider. I'm gonna create a new script, and this was all from last week. And basically, if I run it, it will give me the solution to this system of equations, right? So I have two outputs. The first one is the determinant, and the second one is the solution to the system of equations, which was 4x plus 3y equals 20 minus 5x plus 9y equals 26. Okay, so now let's say I want to convert this into a function, right? So what I'm gonna do is I'm gonna, again, write my define function. Let's call this function equation solver. Define equation solver, my brackets, and then my colon here. And then I'm gonna select the commands and tab just to identify the hierarchy. And what should this function take as input? It should take two arguments. The first argument will be the array A, and then the second argument will be the array B, right? A is the array containing the coefficients of the equation, and B is the vector, or the array containing the numbers on the right hand side, or the constants of these equations. Okay, A, B, and I just initialize them as arrays. And again, to initialize arrays, you just use the square brackets in this case. And what I'm gonna do, I'm just gonna make some changes. So here I'm gonna just write the determinant of A is, just so that's easier to see these results. And then here I'm gonna say the solution to the equations, or just to make it easier. And now then I'm gonna cut out this input, right? So this is the generic form of this function. If I run it, just to see if I have any errors, and as you can see, we have an error here. It's not happy about this. I think this has to be double quotations. So let's just change it to double quotations. And again, this I think should be double quotations. Let's do this as well. Let's run it. Again, it's not happy. Maybe it should be single quotations, actually. Pretty sure it should be a single quotation mark. Let's see, let's run it again. I think perhaps you meant this. Why is this not happy? Oh, okay, it wasn't happy about this equal sign here, which I removed, so it should be fine now. Okay, so now there are no errors, so this function is good as is. So now I'm going to test this function, and I'm going to test it with the input we have. So if I have equation solver, and then I'm going to say A comma B, and if I run it, it will tell me determinant is this and the solution is this. And this makes it much easier. So now if I have a bunch of equations, let's say I want to solve a 3x3 matrix, I'm going to have, let's say 4, 3, 3, minus 5, 9, 12, and then maybe 4, 7, 1. And the array here will be 20, 26, 13. Let's see if there's a solution to this. And I run it, and it still gives me a solution. Terminate is this, and the solutions are this. Okay, so this creates this equation solver. Instead of typing, I mean, this is already an easy or a simple type of list of commands, but it's a gateway to, equation solving, where let's say you want to use a similar approach to solve differential equations. You want to find eigenvalues, eigenvectors. If you take some advanced math courses, maybe you want to test the stability. All of this stuff, you can put all of these commands here, and then just use one line to call it, and you get your solution to this command. Okay, so this is the last example for today's lecture. We have some homework problems, and again, the homework problems are very similar to what we did in class. Take your time and do them. A lot of them you already have the solutions for. So actually all of them you already have the solutions for from the previous lectures. You just have to convert some previous script we wrote into a function. Okay, take your time, try them. This will be due on Tuesday, April 27th by the end of the day. If you have any questions, please come to office hours. They're every day from 5 to 7, or send me an email. I will get back to you as soon as possible. Next week, hopefully, will be a review week. I don't think we'll cover any new material. We'll just review over the different things we did throughout the semester, and it will be the last lecture for the semester. And you might have a homework set as well for next week. Okay, thank you very much, and I'll see you next week. Take care.